Good morning, dear students. Today I am going to teach you a creative question of environmental chemistry, and this creative question is actually related to the deviation of real gases from ideal characteristics. Students, you have learned about the Amaga curve, and also you have learned about the reason of deviation of real gases from ideal characteristics, and based on that theoretical questions this creative question is given here. Now look at the whiteboard. Here PV versus P graph is drawn here, and in this case the ideal gas line is parallel to the pressure axis, and the A gas and our B gas are deviated from the ideal characteristics respectively, and you are seeing the whiteboard. A gas is the prime gas of greenhouse gas. I mean, A gas is mainly responsible for the greenhouse effect, and you know that carbon dioxide is the mainly responsible for greenhouse effect. So dear learners, you can realize that A gas indicates carbon dioxide, and again B gas is the lightest gas. You know that hydrogen is the lightest gas, so B indicates hydrogen gas. Dear students, now question on C. Find out the RMS velocity of gas A stated in this tab. Students, we know that RMS velocity C is equal to root over 3RT by M. Students, in this case you have noted that gas A indicates CO2 gas. So boys, here M is equal to atomic mass of carbon is 12 plus 16 into 2 is equal to 44, and the temperature, it is given 0 degree centigrade temperature, so it will be 0 plus 273 Kelvin is equal to 273 Kelvin, and molar gas constant 8.314 into 10 to the power minus 7 arg Kelvin inverse mole inverse. Dear learners, actually molecular mass is 44. It is naturally in CGS unit. That's why I have to use here the value of R in CGS unit, and that's why I have written here 8.314 into 10 to the power minus 7 arg Kelvin inverse mole inverse, and this is the CGS unit. Then I have to put the values of R 8.314 into 10 to the power 7 and T 273 divided by molecular mass 44. So or C is equal to 3933.8.756 centimeter second inverse. So C is equal to 393.38 meter second inverse. That's all about the RMS velocity of gas A. Dear students, now look at the question on D. Analyze the type of deviation. Here, if you observe the deviation graph, you will see that the red color graph, I mean the deviation of a gas, is initially goes to the downward, then suddenly it goes to the upward. So I can say here this is actually negative deviation. But if you observe the gas B, I mean hydrogen gas, you will see that hydrogen gas is deviated from ideal gas directly and it goes to the upward directly, so that I can say this is a positive deviation. Now I have to establish the deviation occurs here positively in case of B gas and deviation occurs here negatively in case of A gas. Mathematically I have to establish it. Dear students, we know that comprehensively coefficient Z is equal to PV is equal to RT for 1 mole gas. So dear students, I can say the ratio of multiplication of pressure and volume and multiplication of molar gas constant and temperature is called comprehensively coefficient. If the value of comprehensively coefficient Z is equal to 1, then you have to understand that the gas is ideal gas. And if the value of Z is less than 1, then you have to understand that the gas is deviated from ideal characteristics and it is negative deviation. Negative deviation, and if the value of Z is greater than 1, then it is also deviated from the ideal characteristics and it is positive deviation. Dear learners, in case of gas A of the stem, Z is equal to PV by RT. Here the value of PV is 18 and R means 0.0821 liter atmosphere, Kelvin inverse mole inverse, and pressure temperature T is equal to 0 degree centigrade, I mean 273 Kelvin is equal to 0.803. So learners, I can understand easily here the value of Z is less than 1. So in this case negative deviation takes part here. I mean carbon dioxide goes downward from the ideal line initially. That's all about the negative deviation of carbon dioxide gas. Dear students, again if I observe the deviation of gas B, I mean hydrogen gas, I can write here Z is equal to PV by RT. Here PV is equal to 26 and R is equal to 0.0821 and temperature is 273 Kelvin. It is given here. It is stated that the value of P is given in atmosphere unit. That's why I have to use the value of R in atmosphere unit, and the result is 1.16. So dear learners, it can be understood easily. The value of Z is greater than 1, and you know that if the value of Z is greater than 1, it will be the positive deviation. So here hydrogen gas is deviated positively, it means it is deviated to upwards from the ideal gas line. So hydrogen gas is deviated positively. Dear learners, that's all about the positive and negative deviation of a real gas from the ideal characteristics, and this question is very important for your upcoming exam, and also it is very important for board exam also. And no more today. Goodbye.